Hi everyone, welcome back to my videos. I like to do a tutorial on the different types of angles related to circles. We've already seen the betweenness property for segments, the length of segment AB plus the length of segment BC equals the length of segment AC, where A, B, C are collinear. So there's a similar postulate for arc angle measures, and it is the measure of arc AC is equal to the measure of the arc AB plus the measure of arc BC. So we get this plus this equals this whole piece. So a full rotation of a circle is 360 degrees. So the measure of arc AB plus the measure of arc BC plus the measure of arc CA is equal to 360 degrees. So let's look at these different types of angles related to circles, and we consider cases based on the position of the vertex angle. So case 1, the vertex is at the center of the circle. So here angle AOB is a central angle, right? We've seen that before. And the measure of angle AOB equals the measure of arc AB. Case 2, the vertex is inside the circle but not at the center. So here the vertex is V, point V. And angle 1 is going to be the chord-chord angle. And we call it a chord-chord angle because the sides of the angle are both chords, right? AD and BC. And remember, a chord is a segment joining two distinct points in a circle. So the measure of angle 1 is equal to 1/2 times, in parentheses, the measure of arc AB plus the measure of arc CD. We can also choose angle 2 as a chord-chord angle, but when we measure angle 2, we use different arcs to do that. So just bear in mind that there's more than one chord-chord angle. So case 3, we can break this up into two subcases. The first subcase, both angle sides are chords. So angle 1 is an inscribed angle, right? Because the vertex is on the circle and the sides are chords of the circle, right? So measure of angle 1 is equal to 1/2 times the measure of arc AB. And this is probably the most important angle out of all the angles we're studying here. So be sure to memorize this formula. The other subcase, one angle side is a tangent line and the other is a chord. So here one's a tangent and the other is a chord. And that's angle ABC is a tangent chord angle. Measure of angle ABC equals 1/2 times the measure of arc AB. So the last case is the vertex is outside of the circle. So we can break this into three subcases. So in the first subcase, both angle sides are secant lines. So angle P is called a secant-secant angle, right? First secant intersects a circle at 2 points A and B. The other secant also intersects the circle at points C and D. So measure of angle P equals 1/2 times, in parentheses, the measure of arc BD minus the measure of arc AC. The second subcase, one side is a tangent line and the other is a secant line. So QA is the tangent line and this line QC is going to be the secant line, right? Angle Q is called a secant tangent angle, and the measure of angle Q equals 1/2 times, in parentheses, the measure of arc AC minus the measure of arc AB. And then the last subcase, both sides of the angle are tangent lines. So angle R is called a tangent-tangent angle, and measure of angle R equals 1/2 times, in parentheses, the measure of arc ANB minus the measure of arc AMB. So in general, let X be the angle of interest. If the vertex is at the center of the circle, then the measure of X is equal to the measure of the arc. If the vertex is inside the circle but not at the center, then the measure of angle X is equal to 1/2 times, in parentheses, the measure of arc 1 plus the measure of arc 2. If the vertex is on the circle, then the measure of angle X is equal to 1/2 times the measure of the arc. If the vertex is outside the circle, then the measure of angle X is equal to 1/2 times, in parentheses, the measure of arc 1 minus the measure of arc 2. So these are just the general formulas to remember for these different angles. So remember the acronym ISOD. stands for inside sum, outside difference. So if the vertex is inside, we have a sum, and if it's outside, we have a difference. Let's do a true or false quiz based off of what we've done so far. Now, I don't generally like giving true or false or like multiple choice type stuff. I know a lot of people who don't learn well that way, and you know, my goal is not to trick you or not to kind of, you know, make you fall into a trap or something like that. I want to be as straightforward as possible when I'm presenting this material. So that said, I think that this is a good opportunity to do a pretty straightforward true or false based off the stuff we've reviewed. So first one is angle 2 can be measured by the formula type 1/2 times the measure of the measure of the arc. So look at angle 2. It's formed by these two tangent lines, right? Or two tangent segments, actually. We know that the vertex is outside of the circle, right? If we remember that acronym ISOD, inside sum, outside difference, then we should see some kind of difference in this formula, but we don't. So we know automatically that statement 1 is false. Okay, angle 1 can be measured by the formula type 1/2 times, in parentheses, the measure of arc 1 plus the measure of arc 2. So angle 1 is down here, and the vertex is inside the circle but not at the center. And its sides are given by these two chords, right? So it's a chord-chord angle. And we've seen before that, you know, it's given by this formula. So this is true. Okay, so angle 3 can be measured by a formula type measure of arc. So angle 3 is a central angle, right? And it's true that it could be measured this way, right? Because we've seen that the measure of a central angle is equal to the measure of the arc, right? Okay, angle 5 is a chord-chord angle. This is true. The vertex is inside the circle, right? And the sides are chords, right? So we've seen that more than one type of angle could be a chord-chord angle, right? So this is true. Angle 4 is an inscribed angle. So angle 4 is right here. You know, one side's a tangent and the other is a chord. So this is false. So this is actually a tangent chord angle. It's not an inscribed angle. Angle 4 can be measured by formula type 1/2 times the measure of arc. That's true. All angles with vertices lying on the circle can be measured by this formula here, so that's true. Okay, so example 1, given a circle of center O, measure of arc AB equals 45 degrees. Find the measure of angle 1. So write down what we know. And we know that angle 1 is a central angle, right? Because angle 1's vertex is at the circle center. So the formula for the central angle measure is measure of angle 1 equals measure of arc AB. And we can do some substitution and get measure of angle 1 is equal to 45 degrees. Example 2, given a circle of center O, the measure of arc BC is equal to 160 degrees. Find the measure of angle 1. So write down what we know, and we know that angle 1 is an inscribed angle. Angle 1's vertex is on the circle, and its sides are chords. So we can use the formula for the inscribed angle measure. Measure of angle 1 equals 1/2 times the measure of arc BC. So the measure of angle 1 is equal to 1/2 times 160 degrees, which is 80 degrees. Example 3, given a circle with center O, the measure of arc AB is 50 degrees, and the measure of arc CD is 70 degrees. Find the measure of angle 1. So we write down what we know. And we know angle 1 is a chord-chord angle. Why? Because angle 1's vertex is inside the circle, not at the center, and its sides are chords. So we can use the formula for the chord angle measure. So the measure of angle 1 is equal to 1/2 times the sum of the measure of arc AB and the measure of arc CD. And then the measure of angle 1 is equal to 1/2 times, and we can just plug in these values, right? 50 plus 70, it's 120. So 1/2 times 120 degrees is 60 degrees. Okay, example 4. We're given a circle of center O. Measure of arc AB equals 20 degrees, and measure of arc CD equals 60 degrees. Find the measure of angle 1. So we write down what we know, and angle 1 is a secant angle, right? Because, you know, this line, excuse me, this line PC is a secant, and this line PD is a secant, right? A secant intersects a circle 2 points. So the measure of angle 1 is equal to 1/2 times, in parentheses, the measure of arc CD minus the measure of arc AB. We can plug in some values here to get measure of angle 1 is equal to 1/2 times 60 degrees minus 20 degrees. So this is 40 degrees divided by 2 is 20 degrees. So let's go over some problems. So problem 1, given a circle of center O, measure of angle 1 equals 25 degrees. Find the measure of arc BC. So write down what we know, and we know that angle 1 is an inscribed angle because angle 1's vertex is on the circle and its sides are chords. So the measure of angle 1 equals 1/2 times the measure of arc BC, which is the formula for inscribed arc angle measure. And the measure of arc BC, if we do some algebra, we get 2 times the measure of angle 1, and the measure of arc BC equals 2 times 25 degrees equals 50 degrees. So problem 2, given a circle of center O, measure of arc CD equals 170 degrees, measure of arc BD equals 140 degrees. Find the measure of angle 1. So write down what we know, and if we add these 3 arcs together, we should get 360 degrees. So I'm not going to make a distinction which direction we measure the arc. We'll just say it's the same, right? So measure of arc BD plus the measure of arc BC plus the measure of arc CD equals 360 degrees. And if we plug in what we have in statement 2, statement 3, and statement 4, we get the measure of arc BC is equal to 50 degrees. Now we know angle 1 is a secant tangent angle because the vertex is outside the circle. One side is a secant segment, and the other side is a tangent segment, right? A secant segment intersects the circle into 2 places. So the measure of angle 1 equals 1/2 times, in parentheses, the measure of arc CD minus the measure of arc BC. So if we plug in what we have in statement 2 and statement 5 into statement 7, we get measure of angle 1 equals 1/2 times 170 minus 50 degrees. What's that? 120 degrees divided by 2 is 60 degrees. Okay, so problem 3, given a circle of center O, the measure of arc DB equals 130 degrees, the measure of arc ED equals 100 degrees, and the measure of arc CE equals 80 degrees. Find the measure of angle 1. So write down our givens, and we know if we add these 4 arcs together, we should get 360 degrees, right? Their measures together, I mean. So we can use our arc addition postulate, and full circle measures 360 degrees. If we substitute what we have in statement 2, statement 3, statement 4 into statement 5, we get the measure of arc BC is equal to 50 degrees. Now, angle 1 is a secant angle, right? Because angle 1's vertex is outside the circle, and both sides are secant lines, right? A secant line intersects the circle in 2 places. So the measure of angle 1 equals 1/2 times, in parentheses, the measure of arc ED minus the measure of arc BC. And if I plug in what I have in statement 3, statement 6 into what I have in statement 8, we get measure of angle 1 equals 1/2 times, what is this, 110 minus 50 is 60 degrees. 60 degrees divided by 2 is 30 degrees. So measure of angle 1 equals 30 degrees. So we're going to do our last problem here. Given a circle of center O, measure of arc BA equals 60 degrees. Measure of arc DC equals 40 degrees. Find the measure of angle BMC. So write down what we know, and we know that angle BMA is a chord angle. So the measure of angle BMA equals 1/2 times, in parentheses, the measure of arc BA plus the measure of arc DC, right, for the formula for chord angle measure. So if I plug in what I have in statement 2, statement 3 into statement 5, we get the measure of angle BMA equals 1/2 times, what is this? This is going to be 60 plus 40 degrees, 100 degrees. So if we divide it by 2, we get 50. So, but we're looking for angle BMC, right? Well, we know the measure of angle BMA, and so if we add that with measure of angle BMC, it should be 180 degrees, right? Because this is a straight line. So a straight line in a straight angle measures what? 180 degrees. So if we, plug what we have for measure of BMA into this equation, statement 7, we get measure of angle BMC is equal to 130 degrees. So that's all I have for you tonight. This video was not very theoretical. It was more computational. So I'll do probably a video where we prove some of the stuff related to, chord, angle measures and all that. And I just wanted to see if you could, just learn kind of like the formulas and how they're applied in everyday problems. So anyway, I hope you enjoyed my video, and I hope to see you during my next tutorial. All right, have a good night, everyone.